Welcome to the first episode of Pastel project Devlog. Pastel project is a code name for a game I'm working on. I don't really know the exact story the game will have, so can't really decide on a good title yet, hence the abstract code name. In this first episode, I'd like to show you how to easily set up a camera system in a 2D game using a library I have created and open sourced. As I have said in the previous video, I'll be trying to extract as much of the code from my game that can be used by others and open source it and into a free library. This camera system is heavily inspired by a GDC talk, How Cameras in Side Scrollers Work, that you can watch on YouTube, and I really strongly recommend you to do so. Link is in the description. The library I'm providing comes with one main class for the camera part, which is called Focus Camera Controller. It has one method that you will be calling generally in your game, which is called update, which you have to call on each frame. The general idea behind the Focus Camera Controller that it has two parts. One is the focus, which describes what camera is supposed to focus on showing, and constraints, which basically define what kind of additional constraints you want to put on the camera. In most of the games, the focus that you're going to be setting on the Focus Camera Controller is the player character, so the sprite of the player character on the screen. However, this can be modified to provide some more information to the user, or in case of multiplayer games, or in case where you want to show a battle scene between the player and another enemy or some other character, to frame the camera better, to show the actual action of the game. The easiest setup is to set up the focus to be the sprite of the character that you want to show on the screen, and by a constraint specify where on the screen, in screen coordinates, you want this character to appear in. So this is going to be looking like this. We have a character in the middle of the screen. The plus sign or the crosshair is where the focus of the camera is set. And as we can see, as we move, the camera is moving, and the crosshair is always appearing in the exact middle of the screen, so 0.5 in screen coordinates. This is, of course, not ideal, especially in this case where we are seeing stuff that is clearly something that we don't want to hide because it's below our scene. So to do that, we can add additional constraint. And this constraint is specified afterwards, the log to camera constraint, which defines that we want to constrain the camera to only show stuff that is within our scene. The order of the constraints that are passed to the camera are very important because they are processed in the order that we specify them. So first we want to specify that we want to make sure that the focus of the camera is set in the middle of the screen, and afterwards we want to make sure that we move the actual screen a bit to make sure that we don't show pixels outside of our bounds of our scene. And this is how it looks like. We have a character here that once again moves here. Camera moves with it. However, we never go below. The camera will never show anything that is below the defined scene bounds. In most games, what's in front of the character is much more important than what's behind the character. Therefore, you might want to move the focus that you define to be extra pixel in front of the camera, which depends on the way character is oriented. So when your character is looking left, you might want to move the camera to the left of the character, and when it's facing right, to the right character, and same up and down in case you have a top-down view. So when we do that, however, that's how it works. As you can see, the focus is set in front of the character, whether it looks right or left. However, the problem is that we have this jump whenever a character turns around. To fix this, what we can do is to add an additional constraint to the Focus Camera Controller, which will basically move, rather than always focus the camera on the focus point, it will move the camera towards this point from wherever it is now. So this is how it looks like. So instead of the lock to camera constraint, we have the snap to window camera constraint. And so in here we have new kind of idea introduced, which is the window, which is basically a rectangle defined in screen coordinates. As you can see in this example, this rectangle is actually being drawn so that we can see what we mean, where it is. And the way it works is that whenever the character moves, the camera will try to get the focus that is being defined to be within this rectangle on the screen. The problem with this, however, is that the character could run away from this window if the way you define it is that the speed that the camera is moving at is slower than the speed of the character, which would result in the character being actually out of screen. What we can do is introduce another constraint which locks the focus to another window within our scene. And so in this example, we have the window that defines where we want the focus to be, and we're going to be moving the camera so that this point is within this rectangle, this window. However, it will always ensure that if the focus is outside of this red window with a larger one, it will always snap to it even regardless of the speed of the camera. Of course, we also have an additional constraint here which defines that the camera should be within the scene. And now what we do here is that whenever character moves, we always first try to make sure to move the camera with the defined speed to fit the focus within the smaller window. However, if the focus ever goes outside of this red, larger window, we'll move the camera regardless of speed. And that allows us to make sure that character doesn't run away from the scene and is not going to be outside of the scene itself. This setup is very flexible because you can define the focus and the constraints as you see fit, and you can add your own. For example, there is a pixel perfect one which basically rounds the camera position and the camera viewport size to integers. That way you can always have the pixel perfect. As an example, take the Super Smash game where you have multiple characters on the screen and you want to make sure that they are always shown on the screen regardless of their position. And to achieve that, we basically expand the camera viewpoint as is required. And to achieve that, what we do is we use this fit all camera focus, providing the entity focuses here, and this entity foci. And so this basically calculates the center of all the characters or all the focus points and defines this as a focus point for the camera. And this fit all camera constraint make sure that the viewport is large enough that all the characters or the foci that are being defined are fitting on the screen. As you can see in here, I also have the minimum viewport camera constraint, and that is because if all our characters are really close to each other, we do not want to make the camera viewport so small that the character is going to be huge on the screen. We define a healthy minimum for the viewport size. I hope you found this useful. I've provided a lot of links in the description to the library, to the libgdx-graph, and also to the GDC talk. And so please consider subscribing and liking the video. Thanks for watching. Bye.